Professor Luc Tappy, currently at the Inselspital Bern, spoke about the physiology and metabolism of carbohydrates and why not all carbohydrates are equal at the Nestlé Research Symposium Nutrition Live Online 2020, which was scheduled for the American Society for Nutrition. Carbohydrates are formed of one or more monosaccharides and can be classified into digestible carbohydrates such as sugars, starch, and maltodextrins, and undigestible carbohydrates, also known as dietary fibres. Digestible carbohydrates function as energy providers, energy storage, and as part of macromolecules such as nucleic acids and mucopolysaccharides. These carbohydrates are not essential. Dietary fibres, which are undigestible by the human digestive enzymes, may serve as prebiotics and thus support gut health. Dietary fibres provide little energy because of their bacterial metabolites, namely the short-chain fatty acids. As the primary function of carbohydrates is to provide energy, carbohydrate quality can be assessed by their efficiency in providing energy to cells, which is related to their digestion and absorption in the gut, and efficiency in providing usable energy to cells. Another criteria can be the absence of adverse effects on health, such as not inducing excessive energy intake, or not increasing risk factors of non-communicable diseases, especially diabetes mellitus, cardiovascular diseases, or non-alcoholic fatty liver disease. Glucose, fructose, sucrose, and lactose are the predominant sugars in food. Although the monosaccharides glucose, fructose, and galactose need no further digestion, the disaccharides lactose and sucrose are broken down to their monosaccharides by enzymes located on the intestinal brush border. Glucose and galactose are completely absorbed, whereas less than 100% of the ingested fructose reaches systemic circulation. The digestible starch is typically broken up into smaller components and then further broken down to glucose, which is then completely absorbed. Once glucose, galactose, and fructose are absorbed and enter the bloodstream, the related energy available to the various body cells depend on the number and type of transformations in the liver. Overall, glucose has the highest energy efficiency and fructose the lowest. The adverse effects of fructose and galactose on metabolic health are discussed. Fructose increases blood triglyceride levels, an effect that is dose-dependent and higher than the effect of excess energy intake. Fructose may cause hepatic fat deposition and impair the control of food intake. Consumption of galactose with a high-fat beverage increases blood triglyceride levels similar to those of fructose. On the basis of these data on single carbohydrates, glucose and starch have the highest and fructose the lowest quality. But what is known about the quality of carbohydrate-containing foods? Epidemiological evidence indicate that the risk of developing non-communicable diseases is low with the consumption of fruits and vegetables and dairy products, despite high levels of sugars in some fruits. Although fruits can contain the same type of sugars as sugar-sweetened beverages, namely sucrose and fructose, these beverages are associated with an increased risk of non-communicable diseases, especially obesity. The beneficial effect of fruits is maybe due to their other components. Similarly, whole grain cereals or cereals with a high fiber content are associated with a reduced risk of non-communicable diseases, whereas refined cereals are not. What are the potential mechanisms or factors explaining the different effects of carbohydrates in food groups? Among the mainly discussed mechanisms is the type of starch in the consumed food, whether it is rapidly or slowly digestible starch or undigestible resistant starch. Owing to the method of cooking or the way food is prepared, the percentage of rapidly or slowly digestible starch or undigestible resistant starch in the food can change, as shown for white flour and related products such as white bread or spaghetti, or freshly cooked beans and canned beans. Another potential mechanism explaining the different effects of carbohydrates in food groups can be related to their dietary fiber content. Dietary fiber in food can have several beneficial effects, including slowing down of the gastrointestinal transit time or a delayed glucose absorption. Dietary fiber, especially soluble dietary fiber, is fermented to short-chain fatty acids by the gut microbiota, with beneficial effects on the gut tissue and metabolic health. For example, short-chain fatty acids simulate satiety signals and thus play a role in the regulation of food and energy intake. Some dietary fibers have a prebiotic effect by stimulating the growth of beneficial gut bacteria, which in turn may produce short-chain fatty acids. Further potential mechanisms include the glycemic response of food, such as the glycemic index or glycemic load, and other factors in food, such as polyphenols, minerals, or antioxidants. In summary, the quality of carbohydrates can be assessed by the energy efficiency and absence of adverse health effects of the carbohydrate alone or in the context of food. Carbohydrates in sugar-sweetened beverages have the highest energy efficiency and the lowest absence of adverse health effects, whereas whole grains have the lowest energy efficiency and have one of the highest absence of adverse health effects. In addition to whole grains and fruits, the absence of adverse health effects of many carbohydrate-containing foods needs to be further investigated.